Hey guys, here comes the explanation for the quotient rule. And it's going to be a little bit like the product rule that we just did if you watch that video, but obviously the algebra is a little more complicated simply because you're dealing with a quotient. So this is what we're starting with, and we got to go old school, so we got to use our limit technique. So if I take the limit as h goes to 0, I have f of a plus h over g of a plus h minus f of a over g of a, all over h as h goes to 0. So when we've had problems like this in the past, we would find a common denominator. Hopefully things cancel out and simplify, and we'll go from there. So the first thing we can do is at least get a common denominator. So if I do that, I need a g of a over here. I need a g of a plus h over here. My common denominator will be the product of those two, and the whole thing will still be over h. So here's plan A. So g of a, f of a plus h, minus f of a, g of a plus h, all over g of a plus h, g of a, all over h. All right, is it crazy enough yet? Because it's about to get crazier. I'm going to bring this h into the denominator because technically that's just h over 1. If I divide a fraction by a fraction, I can multiply by the reciprocal. So that should take care of that. So let me just clean that up for a second and see what we got left over. So that's g of a, f of a plus h, minus f of a, g of a plus h. I didn't even change that yet. All over h, g of a plus h, times g of a. Okay? So not terrible. A little bit like what we did before. Let's go up here and make our space for our little shenanigans move. Oop, that says h goes to 0. So this is g of a, f of a plus h. Leave some space, f of a, g of a plus h. All over h, g of a plus h, g of a. All right, so what do we put in there? I can't do exactly what we did before because I need to force this to match the common factors that I know we need. And because I know what we need, I need to go ahead and subtract out f of a, g of a. And then I need to add back in f of a, g of a. And how would you know that? Well, unless you've taken the course before, you probably wouldn't know that. But if you did watch the product rule video, you'll know where we're trying to get to. We're trying to get to our old school definition of derivative. So it's right here. We're trying to get to our old school definition of derivative. It's right here. It's a little backwards over here, but we can fix that pretty quickly. So watch this. If I do it here, if I take out, in this case, I take out the g of a, look what's left. I'm left with f of a plus h minus f of a. So we know that part's good. Now this one, it's a little backwards, because if I take out f of a, look what I'm going to get. G of a minus g of a plus h. That's backwards. So instead, I'm going to take out a negative f of a. If I take out a negative f of a, I'm left with g of a plus h minus g of a. All over h, g of a plus h times g of a. Oops, g of a. So take a look again. If I take out f of a from g of a, from this one, I'm left with f of a plus h minus f of a, which is perfect. No big deal. But on this side, if I were to take out the f of a as is, I'd be left with g of a minus g of a plus h. But I know where I'm trying to get to. I know I'm trying to make this look like a derivative. So instead of taking out g of a and adding a step, I'm just going to take out, f of a. I'm just going to take out negative f of a. So that flip-flops these two terms, and I'm left with g of a plus h minus g of a. You can kind of see where this is going. Limit as h goes to 0 of this part. Well, there's your f prime. Of this part, well, there's your g prime. Let's clean that up. Limit as h goes to 0. I'm going to have g of a, f prime of a, minus f of a, g prime of a, all over g of a plus h times g of a. So now you're wondering, well, where did all these things go? Well, again, the limit as h goes to 0 of this part right here is our official definition of derivative. The limit as h goes to 0 of this part is our official definition of derivative just for g. What about here? Well, the h went away because I already used the limit as h goes to 0 for those parts, but I still have an h here. Well, that's just going to go to 0. So look what's left. G of A f prime of A minus f of A g prime of A all over g of A times g of A, which in other words is g of A squared. So if I want f prime of x, I'm going to get g of x f prime of x minus f of x g prime of x all over g of x squared. Derivative of f over g is square the denominator, leave the denominator alone. This is f prime, it didn't come in very good. Leave the denominator alone, derivative of the numerator, minus leave the numerator alone, derivative of the denominator. And there is your quotient rule. Okay? Do I expect you to recreate the wheel every time? No, of course not. But you wanted to know where it came from. I wanted to show you where it came from, so here's where it comes from. If you have any questions, please just let me know, and I will talk to you later.